Hey guys, so what we're going to do today is just try to work with rational expressions because one of the most difficult things is just figuring out how to look at a rational expression and decide which one of the numerous things that we've gone over applies. And so I tried to distill my own thinking when I look at a rational expression down to something that you can follow. So the first thing on all of these is don't overwork the problem if you actually have something simple. So look at our checklist, and I'll put this on Canvas for you so you can look back at it, and I'll refer to the colors as we go through some examples. But you may not need u-substitution. If you have a single term denominator, a monomial on bottom, and STD, you don't need u-substitution. Just separate and reduce in the individual terms and use your basic rules of integration. If you have a number over a linear expression, so if you have something like 5 over x plus 6, guys, you can go straight to logs. You might already have an arc trig function, and so there's no need to do anything except just recognize the arc sine or the arc tangent structure. All right, if you have an expression that's quadratic or higher, I would always check to see if it factors, because if it factors, either the expression could be simplified, you might have the square or the cube of something familiar, or you might be able to reduce, like something might cancel out of the fraction. And when you reduce the fraction, you rebound back into one of the red scenarios. Third, if the fraction's top heavy or if it's balanced, that usually means you can go right into a simple u substitution, which the u will become linear, which leads you into the whole funky u kind of thing. Or you can just do longer synthetic division and usually get around u-substitution in that case as well. Now, the most frequent method you'll use is the blue method. So just remember, most often, blue is for u. Yes, I know it's corny, but you also know that that's how I do things. So most of the time, when you have a fraction, you're going to set either the entire bottom equal to u, or if you recognize that the bottom contains a composite function, an f of g of x kind of thing, you're going to let the u be the inside of it, and you'll just roll from there. That's your most common strategy. The first three strategies, the red, orange, and green, are great, but they don't come up that frequently in this particular chapter. But they do when you get out of this particular chapter and you're just looking at a whole compilation of calculus topics like you would on the AP or CLEP exams. All right, last but not least, if you start to do u-substitution, whether you're letting u be the entire bottom or u be the inside portion of something that sits on the bottom of the fraction. If you realize that what you're letting u be is more than 1 degree higher than whatever's on top, back up, look to see if you can't somehow rewrite it as an arc trig function. So if there's no square roots, you're probably working with arc tangent. If there's a square root in the denominator, you're probably somehow working with arc sine. Now, let's try some practice problems. So I think it's helpful if sometimes you see problems that are really similar and we talk about what makes them different. Your textbook, if you looked at all of the problems that I was doing on your textbook from the same page 547 or whatever it was, you should have realized I kept asking you to do more and more problems on that page. And so if you look, sometimes two problems that were right beside each other were extremely similar, but I gave them to you on different days. So let's begin to analyze. Now, when I look at this one, I'm wondering, do I have to do any u-substitution at all? Well, the first thing that catches my eye is that it's top heavy. So as soon as I see that it's top heavy, and neither the monomial nor the binomial will factor, But as soon as I notice that it's top heavy, I know that my strategy is going to be division, and you'll carry that out. Now, look, number 2 is very similar, but I've switched the top and the bottom. Well, this does fall into the first category. I don't need u-substitution. 2x squared is a single term denominator. So let me rewrite the problem. X over 2x squared plus 1 over 2x squared dx. If I simplify each part, I don't need u-substitution at all. So x over 2x squared reduces to 1/2 x to the negative 1. Let's do 1 over x. That would be better. So that's just going to be a logarithm problem. And then the next one simplifies to 1 over 2 x to the negative 2 dx. So I just do both of these straightforward. Okay, I don't need any u-substitution. Now, on the bottom one, my gut instinct is to let u equal 1 plus x squared, which would make du 2x dx. But wait a minute, I don't have an x up here. Remember, what I want to let u be winds up being degree 2, whereas the top is degree 0. That's the trigger to make me think, wait a minute, is this maybe an arc trig function? Well, yes, of course. This is straight up 1 over 1 plus x squared. So that's just the arc tangent structure. All right, so take a look at these. Now on number 4, again, definitely I don't have an STD on the bottom. Nothing's going to factor. It is bottom heavy. So immediately I start by letting the bottom be 1 plus x squared. Then when I do du is 2x dx, I realize that I can proceed here because the x dx is what would be, well, actually the whole 2x dx is what's on top. So that tells me that I'm going to rewrite this one with u on the bottom, and then the 2x dx becomes 2 or du, and so it's just the ln format, okay? So I'll look at number 5, it's bottom heavy, nothing's factoring. I'm going to go straight to 1 plus x to the 6th. Du is going to be 6x to the 5th dx. And I look and realize I've just got an x squared dx. Okay, that catches my attention. So that's when I need to rewind and say, wait, I wasn't thinking. What I wanted you to be had an x to the 6th power, but the top has an x squared. Those are separated by 4 degrees, not just 1 degree. So now it makes me go, okay, is this actually the structure of an arc tangent function? There's no square root, so it couldn't be arc sine. So when I look at it that way, I realize that I could, I'm going to pull the 2 out, but I could leave x squared on the top. What if I made the x to the 6th, x to the 3rd squared? Now, if I did that, could I rewrite the bottom as 1 plus u squared? And then I still need to do something with the x squared dx. Well, I could do this if I let u be x cubed. Well, what is du then? Well, it will be 3x squared dx. Okay. So the x squared dx becomes 1/3 du. So 1/3 du. So again, we are back in our arc tangent structure. All right, so now I'll look at this one. It's bottom heavy. Clearly, I don't have a monomial or something simple on the bottom. It also doesn't look like that anything on the bottom is in the form of an arc trig function. So when you have something that's quadratic, see if it'll factor. So when I look at this, let's see here. Can I factor 2x squared? So it'd be 2xx. It's got to be 1 and 1. Yes, if I did this, then I could get it to factor, and then look, these cancel. So that means my problem becomes the antiderivative of just 2x minus 1. Well, guys, now we're back up to the red rules. Because this is a number over a linear expression, I could go right to logs. So I know it's going to be ln of 2x minus 1 plus c. But remember, I need to take that 2 and compensate on the outside if I want to get around u sub. Now, you may be still a little iffy on that. And if you are, just do the u sub. If I did the u sub, it would be that u is 2x minus 1. Du equals 2 dx. So I would replace the dx with 1/2 du. So that's where the 1/2 would come from if you wrote out the u sub steps. Now this one has a similar denominator to the last problem, but I put it under a square root. All right, so I'm still thinking there's nothing about that that looks special. Even if I did factor because it's under a square root, nothing's going to cancel. So I'm just going to go ahead and dive in and let u be 2x squared minus 1. Now du is going to be 4x plus 1 dx. And then I'll look at the top of my problem and I'm like, oh no. Well, let me at least clean up a little bit. I've got square root of u. Now, oh, do you see what I see? On the top, I have to be a little bit clever, but if I factor out a 3, then I get 3 times 4x plus 1 dx. And remember, the 4x plus 1 dx is du. So now I've got 3 over the square root of u du. So that means it's doable. So I would pull the 3 out and make it u to the negative 1/2 du. And now just use your exponent rules, your power rule. So on this one, I've got the same numerator as I did in the last problem. I've still got a square root in the denominator, but I've made what's under the square root simpler. So again, the top factors, but there's nothing that's really going to cancel out. There's nothing that simplifies. So I'm just going to dive in because most of the time, the blue is for u. So instead of letting u be the whole bottom, I'm going to let it be the interior portion of the bottom. So that means du equals dx. So I immediately get the square root of u here, and dx I can replace with du, but I've got a little issue with 12x plus 3. All right? Oh, remember guys, u was linear. So it's real easy then to say that x is u plus 1 and to replace the x there. That's real easy to do. So 12 times u plus 1 plus 3 over the square root of u. Now remember, at this point, we're back in the structure on the red part where I don't need additional u substitution. If these were all x's, I wouldn't have done any u sub at all. Because if I distribute, I'm going to have 12u over the u to the 1/2. I'm going to go ahead and separate as I go. Plus 12 plus 3 is plus 15 over u to the 1/2 du. That's going to give me 12u to the 1/2 plus 15u to the negative 1/2 du. And then again, I'm ready to just use my power rules. So for our last example, I just want to remind you, we talked about this yesterday. When I look at it, I don't have a monomial on the bottom, so I can't separate and reduce. The bottom doesn't look like anything that's like trig, arc trig functions. Okay, the only thing I can think of is it looks like the bottom does factor. So nothing's going to cancel, but could it simplify? So I'm going to have 12. And on the bottom, do you see that this is x plus 6 squared dx? Ah, so look, guys, if I pull out the 12, I can make that 1 over u squared. U would be x plus 6. Du would just be dx. So I can immediately replace the dx with du. And guys, you can integrate that because, again, it's just a power rule problem. It almost makes you think it's going to be a logarithm problem, but remember, if it's anything, if u is to any exponent on the bottom besides just 1, it's not logarithms, it's power rule. Now, try your hand at the worksheet that I've attached. I've also attached the answers. Try to just do the worksheet, then check answers, because it's good for you to play around some and struggle a little bit. And once you figure it out, you'll build confidence, and those things that you struggled with will start to stick. And that's what you really want, is to build familiarity and to convince yourself that you can figure out what you're dealing with in each different problem you get to. All right, if you need any help, let me know. Come on into Zoom. I'm more than happy to help you with these. Have a good weekend.